Okay, so this is welcome to Let's Learn How Gravity Works. I say let's. I don't know. I'm going to be guessing. Okay? If I'm wrong, please leave a comment, shoot me a message, send me a text. I don't want to build on what's wrong. Okay? But let's figure out how gravity works. Okay? First thing I want to say, and I think the best place to start in this is at the bottom. Okay? In order to figure out any problem, we got to start at the bottom. So, in this case, I think the bottom is going small. As small as we can mathematically figure. Okay? Or smaller. Just as we can figure pretty far mathematically. Let's go to the smallest thing, the smallest. Okay, and that's where I'm going to start. So I'm going to try and write things down here as we go, just to kind of keep a running record. So we're going to start with smallest. Okay? That's our first one. Start with smallest. Now I already kind of have a game plan in mind of how I want to do this. So the next thing that I want to talk about is this whiteboard. Okay? This particular whiteboard here is the atmosphere of space. Okay? It is space air. It is the atmosphere of space. Okay? So everything I do on here, this will act as the atmosphere of space. Alright, so let me write that down. Center whiteboard equals space atmosphere. All right. Okay. So if we go small and look at, now here's the key, the kicker. If I am wrong, please comment, please call, please message, please tell me, because if I'm building on the wrong information, I need to know. Okay? Can't build on incorrect information, so I'm going to be spitting things out here and explaining things as I understand them, and please correct me where I'm wrong. I beg you. Okay. That being said, the smallest thing, okay, now, this is my understanding, if something has mass, it has its own gravitational pull. It has its own gravity because it has mass. Okay? So let's take a look at a dot. And let me just use a little different color here. I don't know what colors on it, just doesn't matter. I'm just hoping you can see it there. Okay? There's a dot. Yeah, you can kind of see it. So that's our small thing that has mass. Okay? Take a speck of dust and make it, make it small. Smallest thing. Now, it has mass. Now, if it's true that everything that has mass has its own gravity, then essentially this object should have a ring around it. why? Because that is, now here's where I'm going to start guesstimating on my ideas of how this all works. Okay? What is the ring around this object? Okay? If this is the atmosphere of space, and you have a mass, an object with mass in it, it's going to push that space. It's going to stretch the space from inside. It's going to stretch it. Now, well, I'm going to keep talking about this and the properties of what I think is going on there. Okay, so it's stretching space from the inside, it's pushing it out. Now, this ring, gravity, the gravity circle, the gravity bubble, it wants to return to its starting position. Okay? It really wants this mass to be gone because then it can be back to its starting position. But it doesn't. It's got. I guess they call it the weak force is what gravity is, but it's a compressing force, and this could be a number of things. It could be just the space itself trying to reclaim its territory. Okay, and that's one way to look at it, or it could be that little section that is trying to reclaim its territory. Okay, so whether it's the whole or the area, let's just look at a little area and say, it's trying, because this is an object, the dot is an object that has mass, and now mass has its own gravity. Okay, so the ring around it is the gravity. What that ring is the space atmosphere being stretched away from the mass. Okay? It's being stretched away from it. It's not leaving the mass. It's just being stretched away from it. Okay? So there's always a constant weak force pushing back down on the mass, on the object with mass. Okay? So, now how many sensitive points I hit here, but love to hear about it. I'm going to keep moving forward as best I can. All right, so there's one little tiny object. Okay, it's forced the atmosphere of space. It's basically stretching the atmosphere of space. The atmosphere wants to get back in, so it's basically stretching it. The atmosphere allows room, but it doesn't want to break. Okay? So what's going to happen when we stretch something? Okay, you're going to stretch something that doesn't break. Like, let's look at just a basic rubber band. Okay, you can stretch it out. What happens to a rubber band when you stretch it out? It thins out. Okay, but it's under tension. Okay, it wants to come back, but it's under tension, so it thins out. So, it would be safe to assume that in this process of expansion, there would be tendons that would be more it's where the action is happening. So it's the binding agent. Now the tendons could look like this, I got it kind of looking, and you can hardly see this. Maybe I'll move it a little closer. Now, is that close enough? I just don't want to be bottlenecked in this room. Anyway. Okay, so that darn light is right there. Okay, so here, let me just bring it in here. So I drew lines like this, okay? So there's your mass, there's your original gravity bubble, and I'm imagining there are tendon-like features from the stretching of the space atmosphere, okay? So with those, geez, there's no good way to do this. With those tendon-like features, you know, that may explain it in a larger sense of like when the Earth has the northern lights and those lines are coming down, okay, that we see. I'm not going to get into what it is because I honestly don't know the technical terms, ionization, something like that. But there are distinct lines that we see. Now there's a lot of them, but there are distinct lines. Okay. Now I could be completely wrong on that, but that's just an example of what I mean by the possibility of tendons in a gravity bubble. Okay. In a gravity bubble, you stretch the space atmosphere out. And once it gets stretched, it's like a rubber band, and it produces areas of strength inside it, okay? And I think this is real important to understand these areas of strength inside. So, moving on, and feel free. You know, I'm not afraid to be on camera here. And muddle through things. If you have questions, if you know I'm wrong, please tell me how. Provide the where I can find the information, and I'll be happy to change it, and we'll move on and find a new way. Okay. So back to it again. So we're stretched out and have. Okay. So what happens now? Let's introduce another object, another piece of material. Okay, we have another piece of material here. It's moving, for our sake, in that direction. Okay, now it's got its own gravity bubble. Okay, and it's moving that way. Doesn't matter why it's moving. Doesn't matter how it's moving. It's moving. Okay? It's moving. So it's moving that way. So what happens when these two bubbles meet? Okay, now this gets into a whole nother realm of possibilities here. So we could have a situation where when these two objects meet, okay, let's draw two gravity bubbles right next to each other. Okay, and we'll put the objects inside. Okay, the mass objects inside that create the gravity bubble. Now, when they come together, okay, this one's coming to that one. So one thing that we know is going to happen is there will be, and now we can get into elements and everything else right now, but for my sake, let's keep it so it's basic. Because this gravity has a weak attracting force and it wants to retract in on itself, it actually has a pull to it. So anything that kind of touches this, bubble, is going to have trouble escaping it. And unless it's at a higher velocity or whatever, if it hits this bubble, the bubble's going to be like, oh, no, we're here. Well, you know, I'm trying to get back in here. And so objects may touch it and get stuck. So if we have one object there and one object here, so we have two objects now that are kind of getting, and this one here was moving that way. So what's going to happen is when it touches the gravity bubble of the other object, object 1 or A or whatever, there's our spin. Okay? There's our spin. It's going to spin at whatever velocity this object was moving. Okay? Whatever velocity this object was moving, when it touches this, it's going to spin. Okay? Now, whether it depends on the mass of each object, which one's going to spin faster, the rotation, stuff like that, how they're going to spin. But there's where our spin comes from. Okay? Now, what happens to the gravity bubble itself? Okay, now I heard something else, and this is where I have many questions at. I heard something else that there is a length that is so small that it cannot physically touch another thing. Now I kind of think this is a little bit of BS, but at the same time it can make real sense. So, you know, you've heard some people have said that, you know, even though you're touching hands, you're not actually ever touching anything else. If things actually can't touch each other, okay, if they can't touch, if there's that certain length in which things cannot touch each other, okay, that means this object and this object can never actually touch. But because they both have mass and they both have a gravity bubble, they could be attracted to each other and squeeze the space atmosphere, the gravity bubble, you know, I'd say it's a gravity bubble, but it is part of the space atmosphere. It squeezes it, so it could, now this is just one theory, it could essentially put us where we have our two objects like this, but now instead of having one gravity bubble, we have two objects that have squeezed the space atmosphere around it. So it's got a gap because they cannot touch, and it's squeezed the space atmosphere around it. Okay? Now that would be perfect if we were trying to explain a lot of things. And as you can see, those lines, they look very familiar. Okay? You know, when you do you're looking at magnetospheres and stuff like that, you see lines like this. You know? So that makes a lot of sense that it's squeezing the atmosphere. And I actually, right now, I like this theory because it looks right. The other one, and here's my stumbling point with the other one. The other one, if these two masses meet and actually touch each other, then essentially that would just create one big gravity bubble. And that would lead to another issue saying that in order for it to touch the gravity bubble had to be broken right here. It had to break right in between so those two could come and meet. Okay? And it would, the two together would then produce their own gravity, but then there would be no tension lines. Okay? And that's my thinking on why I kind of believe that we're at nothing can touch. Because I'm sort of thinking that there would be no tension lines. Well, there would still be tension lines, but it would split the space around it. And for what we see, what I believe we see in the known universe is that just doesn't happen. Because, all right, what can I get rid of here? Let's see here. Well, let me just jump off to a galactic or solar setting for a second here. So in a solar setting, where you have a sun and you have your planets, the gravitational pull or the magnetic pull of the sun encompasses a very big area. And they call that the heliosphere. I think that's a technical name. Gravity sphere, pretty sure that's wrong. The magnetic hold, pretty sure that's right. I think it's the heliosphere. Is the total control area of the sun. And I say the control area. What I think that means is how much of the space atmosphere is being stretched by the mass of the sun. Okay? So I was getting my point about that. You know, the sun's spinning. Everything we see spins. And I wanted to get back to that point. Why is it spinning? Well, let's go back to point 1 and 2, okay? Even if point 1 is still, not moving, and point 2 is just moving slowly. There is nothing, the space atmosphere doesn't have brakes. It won't, there's no pressure to slow this guy's movement. So he's going to move. So when it does come in contact with this, even if it's direct straight line contact, he's going to transfer his inertia into this guy, and the movement isn't lost. So when the spin happens is when it doesn't hit direct on. They kind of get caught into each other, and the spin happens because there's no air to slow it down. Okay, that's the really hard thing to understand while we're standing here on Earth, because we know when we throw a ball, it slows down. In space, there's nothing slowing it down. So basically what I'm saying is if you go to space right now, all right, and you kind of get yourself out of range of the major gravity pulling areas of the Earth and the moon and even the sun, you should be able to throw a baseball and that thing will go in that direction until it hits something else. Hundreds of thousands of millions of light years later, it should just go. Okay? Unless it comes in contact with another gravity source, there is nothing to stop that thing from moving. Okay? It just goes. Alright, so again, I don't have the answers here. I'm looking for the answers. I think they're important to find. So if you know for a fact that any of this information that I'm giving or trying to sharing is wrong, please tell me, and we'll correct course, and we'll try and figure it out the right way. But right now, I mean, I've covered a lot of ground. That's a lot to take in for a couple dots and circles on a whiteboard. This does have a lot of interest to me. You know, my original thought on doing this, you know, I started a couple days ago, and my thought was, I had this thought in my head that the speed of light is not fast enough. Okay. Oh yeah, it's top speed in the universe. Blah blah blah. It's not fast enough. Like, dude, there's planets out there, and you're telling me we can't even get a message to somebody in our lifetime. Like, if I was a baby and wanted to say hello to somebody, it wouldn't happen in 100 years. It may take 100 years for that message to get a quarter of the way where it was headed. So light speed is just not fast enough. We got to find another way. We got to find a better way, okay? And the only way to find a better way is to try and figure out some of these things that we don't know. So I don't have the answers, but I want to figure them out. So I'm coming back to this gravity thing here, and I'm going to touch base on why I started here. I was doing a video the other day, and I actually got rid of it because I kind of got stumped in the middle. I'm like, oh, I know, but I don't. On how things work, and I had to come back to basics. I had to come back down to the beginning building blocks to start understanding and make myself understand better how things work. Okay, so now I know, and I'm going to keep going here, and Lord help me, hopefully I'm on the right course. I have had no luck with people watching my videos before. None. And this is probably just going to be more of the same. So I'm praying that I get corrected. I'm praying that someone messages me and says, you're wrong, it's this, there's proof, it's been proven, blah, blah, blah. You need to change course. I'm praying that somebody says, or praying that someone says, hey, you know, you might be onto something, whatever, it doesn't matter if I'm wrong or if I'm right. I'm just waiting for somebody to say something, you know. I'm going to keep doing this regardless. I can't escape it. I can't just go do something else and forget about it, because it always comes back to me. It's like, I don't know. It just always comes back to me. It's the most exciting thing for me, and so I should call that my first video. I'm nearly at 30 minutes, so I could keep going. So here's the thing. Here's a question. Here's a good response thing. Do you think that space is, that nothing touches and space is actually stretched out around objects with mass? Or do you think they actually touch, things actually touch, and then we'll have to figure out what's happening with the gravity then? And either way, any information you can provide that would kind of help make me a believer, that at least you believe, and you're like, okay, this is why I think that. I want to hear that. I want to hear why you think what you think. So I want to know here, do you think things and I'm talking the actual things touch. So there's my question. Okay, that's what I'm hoping to get answers on. That's where I'm at in my research. Now, in my video vlog rambling is, I guess, is that video vlog rambling is what this is basically. In my vlog rambling, which I like doing. Do you think things touch? And it's a deep question if you watch the entire video. You understand what I'm saying? Now, I have it here designed to go this way. I mean, if you know that I'm wrong, please provide your own pictures of why it and how our universe can be like it is. Seems like the easiest description. You know, sometimes they say the easiest things, what's happening? Here, you know, it could be the spin. If these things actually touch, it could be the spin. Okay? So this gravity center is getting spun. It's getting spun. Okay, so what flattens it out? You know, if it's spinning, it's going to be compressed a little bit, just because it's spinning from centrifugal center force, whatever you want to call it. I can't even pronounce words. It's going to be you name it. I can't even spit out the word. It's going to be flattened a little bit, which would make sense because we know that the Earth isn't exactly round. It's a little flatter, squashed at the poles towards the equator because of the spin. So that's a possibility. I'm not against it, but I really like the way this one looks. I'm really liking the way this looks. Because if I keep going on, I believe eventually I can spit out why and how there are areas in really massive objects that allow for areas like electrons. Or if you're dealing with the sun, areas like planets. Why are these areas even possible? And I'm pretty sure with my vlog rambling, I can get us to the point as to how those areas are possible, okay, via this method, okay, via the stretching method. Now I'm gonna stop here shortly. I'm gonna post this onto my YouTube page, but I'm gonna also post it onto my ideas page on Facebook. I can't post it on my regular Facebook. I guess I could. You know, sometimes you think it's just a bad idea. It's like a decision you shouldn't do. And it seems like every time I put something just on regular Facebook, I get more people just signing off of me. So I put it on my ideas page. Not too many people go there anyway. So then it's just a hope and pray and beg. You know? Beg, I guess. That somebody's like, hey, you might be onto something there. Okay. Well, I'm going to stop this video. I'm going to take a break for a little bit. And then I'm going to decide if I'm going to come back and do a part 2. All right, thank you for your time.